in progress.
So yeah, they said we should determine the point of contact to the tangent of y is equal to x squared if the tangent is parallel. It is parallel to the line of y is equal to 3x plus 1. Now, this is very important. It helps if you have a graphical representation of what this thing looks like. Remember, this is a parabolic function. Okay? So you can have a rough sketch of the parabolic function and say, okay, but we have something that looks like this. And then here's what they're saying. We do have a tangent to this curve. So it can be a tangent to this curve. Let's say it touches it here. So it's a straight line. It touches the line. It touches the curve only once. Now, this equation that you see here, it's not the equation of this line. This one is not that one. But what they're saying is that this is parallel. So meaning if it's parallel, it could be a line somewhere here. It could be in contact with the graph. It's also possible that it could be just a line outside the graph. It doesn't matter. Now, how do you define this equation of this new line that they gave us? They said it's given as y is equal to 3x plus 1. Yes. Now, they can ask us to determine the equation of the tangent, or they can ask us to determine the point of contact. Then the question is that how do we relate these two lines? One of the first things that they have in common is that both of them are lines. Yes. If something is a line, it means which it can be, both of them, they can be defined by the same equation, which is y is equal to mx plus c. That's the first thing. Okay? Yes. And then you can't talk about m if this thing is not in a standard form. It should be in a standard form. Now, how does it become in a standard form? Y should be the subject. Yes. And then remember, we then advise to each other to say we're going to create a point. Yes. The point, we said we're going to give it an alphabet P. And then we'll ask ourselves, okay, did they give us any x value for this point here? Did they? No. So we don't know what is x. Do we know what is the y value of this thing? No. We have no idea what is the y value of this thing. No? And then we go to point P prime, which is the point below the point. So do we know what is x? We don't know. Do we know what is m? Yes. What is m? 3. We are not sure as yet. We know m of this line. We don't know m of this one. But we can find it. But how to find it? We're going to tell them which we have m parallel. This is the m parallel. What is the m parallel? The m parallel is going to be equal to 3. I will still find. Yes. And then from m parallel, we can tell them, but now they said the parallel, the m parallel and the tangent are parallel to each other. What does that imply as the analytical geometry? If two lines are parallel to each other, what can you tell me about parallel lines? Parallel are the same. So you can say m parallel is going to be equal to m tangent. Yeah? Yes. Then you can then go and update. Otherwise, the variant of the tangent we didn't know. We knew m of the, because it's very important, because not only do they speak about m parallel, they can also speak about m perpendicular. Does that make sense? Mm-hmm. So now you can come and say, okay, but this one is equal to 3. They ask us why are we saying this. We will tell them which is because we have parallel lines. That's why we're saying this. Now, we can then go and update this one and say, okay, yeah, you are going to have 3. So I'm going to put the ones that we are finding with the red color. As soon as you have these, then you can then point to something like this and say, on point P, there's this equation. I don't know what is x, I don't know what is y. I can't use it. Yeah? And you see why they do this, Cotton? It's because they don't want us to use the fact that this one and this one, they are equal. That is why they give you m parallel. They don't give you m. They don't give you the equation of the tangent. Because if they give you the equation of the tangent, then another can come and say, but this y and this y they're equal. Then we can solve it simultaneous. So they are going to try to defer and give you m parallel so that you can't solve it, because they want you to use the calculus. In this question, they want you to use the calculus. Once you see the word tangent and then you see a curve, they want you to differentiate. They don't want you to use any other method. So with that being said, then we are forced to not use this one because we don't know what is x, we don't know what is y. But we can use f prime because we have something on point P prime. How then do we use that one? We're going to tell them which we have f prime of x which is going to be given as 2x minus 1. In fact, I'm supposed to say dy dx here because they gave us 1. Can you see that then? So I'm going to tell them which is dy all over the x, which is f prime of x. Remember, it's the same thing, it's just a notation here. Because they didn't say f of x, they said y is equal to I am forced when I'm differentiating. Now, yeah, they are not necessarily going to penalize you for the notation. They usually penalize you on the notation, on the one when you're differentiating from rules and differentiating from the first principle. And then they're only allowed to penalize you somewhere there. So even if you said f prime of x, I wouldn't hold it against you. So you're going to have dy all over the x, which is m. Then you can come and say we have 3, which is going to be 2x minus 1. Take the 1 to this other side, it says which you are going to have 3
plus 1,
which is going to be 2x. Divide by 2, you divide by 2, it says which x is going to be
2.
It's going to be 2. Update. Two and 2. What is still missing here? We can still find y. How would I find my y then? That's the question. What should I do? I can stop. No?
Yes.
So I'm going to have y, which is going to be given as 2 all squared minus 2. Can you give me something like what? Like 2. So we can come and update and say, okay, but now here's what we have then. We have 2 is to 2. If they wanted the point of contact, we'll stop here. Just like this question, if they said they wanted the point of contact, we'll stop here. But most of the time, for a question like this one, they might be interested in us determining the equation, which is something that we already know because we did it in the previous example. So once you know the point of contact and then you know the gradient, you can come and say, but now y is going to be equal to, you're going to have 3x plus c, which is going to be given as 2 is to 2. So you're going to have 2 is going to be equal to 3 multiplied by 2 plus c. Then you have 3 multiplied by 2 gives us 6. Eh? You take this one to this other side, it says you're going to have what?
Minus 4.
Yeah, minus 4, which is going to be c. Okay, we have c, which is going to be minus 4. Therefore, our equation is going to be y is equal to 3x. Yeah, this is what they usually ask. Determine the equation of the tangent if you are given m parallel or an equation of a parallel line to the tangent. Or if you are not given a parallel line to the tangent, you can be given a perpendicular line to the tangent. Let's check this one. Number 2. If you look at this one here, they say if this is perpendicular to the tangent, determine the equation. Do that one.